Hi everyone. So today in this video we are going to discuss how to solve a physics numerical. Now in this particular case I have selected one question from electrostatics, that is from class 12 syllabus. We are also going to discuss what are the difficulties faced by a student while solving a question, okay, or solving a numerical. Okay. Now normally students hate solving numericals in physics. Okay. So what is the reason? Probable reason. Okay, so those things we are going to discuss in this video. Now as you can see, this question says we have a uniformly charged ring of radius r and carries a charge q. Okay, find the tension in the ring when a charge small q is placed at its center. So first of all, after reading the question, you should be able to visualize what the question says. Okay, now visualize means if it is not possible to visualize, draw it in pen and paper. Okay, so this is the ring. Okay, it is uniformly charged. Okay, uniformly charged means each unit length of the ring will have same charge. Okay, uniform charge means charge per unit length. This is constant. Okay, so see, before solving a question you need to understand what the question says. You should be able to understand the terms which are involved in the question, irrespective of whether those things are required for solving the question. Okay, sometimes those things are not required, but you need to understand the question. So uniformly charged ring means this is a ring which is uniformly charged. Uniformly charged means each unit length of the ring will have same amount of charge. Okay, so charge per unit length is a constant. So we have charge q. This charge q is distributed throughout the circumference of the ring. Okay, now radius is r, so this is the center O, radius is r. Okay, now then they have asked find the tension in the ring when a charge is q is placed at its center. So this charge q is placed at the center. So what is the tension developed in the ring? This is the question. So first of all you need to understand that both the charges are positive charge, means charge on the ring is positive, charge which is placed at the center, that is also positive. Okay, now we have two charges and we have to find tension. Okay, now what is this tension? Now if you remember, in class 11 we have studied the concept of this tension in the chapter laws of motion. Okay, now tension is the force experienced by string or wire in that matter. Okay, so force on wire or string. Now just to remind you what we have learned in class 11, as suppose this is a rigid support, this is a string. So this end of the string is attached to the rigid support. This is the free end. Now to the free end a load is attached. Okay, now this load is having some mass m. So obviously this mass will experience a downward force due to its weight, and that is because of gravitational force. Okay, now obviously this string, see, the string will experience a force in the downward direction because of this weight. Now by virtue of third law of motion, it will also exert a force in the upward direction as a reaction force. So that reaction force is called tension. Now this tension will act in the upward direction. Okay, now this is how we have approached the concept of tension in class 11. Okay, but there is a flaw in this concept. Flaw in the sense, here we have seen that this string is a straight position and tension is along the length. Okay, but we have never seen a condition where you have a bent string. Okay, string is bent, and now in this position you have to calculate the tension. Okay, so actually this tension, it is not along the length of the string, it is always tangential to the point of application. Okay, so the tension, suppose if it is bent, suppose at this position we have to find the tension, so this is the direction of the tension. So tension is always tangential to the point of application. Okay, so this is the idea of tension. Okay, now the second problem or second difficulty in solving this question is when you are asked to find a tension, that means you got this idea that okay, we have to find the force. Okay, and somehow we managed to understand the concept of tension also, that tension need not be along the length of the string as in this case. Okay, tension actually it is tangential. Suppose that concept is understood. Okay, now the second difficulty is if you have to find the force, what law, what formula you are going to use. Okay, now then you will recollect that in the chapter Electric Charges and Fields, that is the first chapter, there is a topic called Coulomb's law. Now this Coulomb's law is used to calculate the force between point charges. Okay, so we have 2 point charges Q1, Q2 separated by distance r. Okay, say in free space. So we have this force F is equal to K Q1 Q2 by r square, where this K is the proportionality constant and its value depends on 2 factors. One is the nature of medium and the second factor is the system of unit you are using. So in case we are using SI system of unit and we have the vacuum or free space, then this K is equal to 1 by 4 pi epsilon naught. Okay, those things we have learned. Okay, we know what is the value of 1 by 4 pi epsilon naught. So if we have 2 charges, we know 2 charges and we know the separation between the charges, then using this formula we can calculate the force. Okay, now this is the understanding of Coulomb's law at superficial level, I'll say. Now if we go a bit deep, then you will learn that there are some shortcomings of this Coulomb's law. The shortcomings are that this Coulomb's law, it is applicable only for point charges. Okay, for point charges only you can use this Coulomb's law. Okay, now what do you mean by point charge? Point charge means size of the charge is quite small in comparison to the separation between the charges. Okay, so that means Coulomb's law is not suitable for calculating the force between extended bodies. Okay, but then in this case we have an extended body, one charge, this charge is a point charge. Okay, that is understood, but this ring, it is not a point body. So this ring, it is having a definite shape and size, and definitely we are not going to ignore the size of the ring. Okay, so how to find the tension? Because Coulomb's law says that it is applicable only for point charges, and this is not at all a point charge. So first of all, you need to remove this phobia that physics numericals are difficult. Okay, they are not difficult, it is just that you need to think in a proper way so that you are able to get the proper solution. Okay, now what is the thinking process? So this is the ring. Okay, so this ring is uniformly charged. So so this ring is uniformly charged. Charge is Q, radius is R. This is center we have charge Q, small q. Okay. Now let us take one small segment. Okay. Now this is a small segment and we are going to calculate the tension on this small segment. Okay. Now the beauty about tension is, if you can calculate the tension at this small segment, it will also be equal to the tension at each of the segment of the ring. Now this is one very important concept that we have learned in class 11, that tension at each and every point on a string is same. Okay. Now provided that string is uniform. So here it is uniform. Okay, charge is distributed uniformly, ring is also uniform. Okay. So for this small segment we are going to calculate the tension, but this small segment we are going to zoom in. Zoom in means, see, it is very difficult to visualize a small segment. So just for the sake of understanding that small segment, we are zooming in. Okay, so the segment is small, but I am marking it as like this. Okay, so this segment I am marking it as like this. This is just for the sake of simplicity of visualization. Okay, now this point and this point, we will mark the direction of tension. Now as I told you, the tension is always tangential to the length of the string or ring or wire. So since here it is bent, so here the tension direction will not be along the length, because as we have discussed previously, for straight wire tension is this, length of the wire is this. But here I have to draw tangent at this point and this point. So this is one tangent, this is another tangent. Okay, so I have drawn two tangents. So this is T, this is T. Because tension, it has to be same at all points. So this is T and this is T, tension. Okay. Now I will connect these 2 points to the center. Okay, center you have charge Q. Okay, then I will connect this to this point also. Okay, now I will draw one horizontal line. Okay, so this, I have one horizontal line and I have one vertical line. Okay, now obviously by symmetry these two angles, they have to be equal. Okay, they have to be equal. Okay, now another observation is, see, suppose this is point A and this is point B. Okay, now if I bring A and B close to each other, okay, so this theta, it will start decreasing. Now if this theta approaches 0, this tangent will almost become horizontal, because if A and B are coming closer and closer, this tangent is going like this in the upward direction. So if this angle becomes 0, this tangent, this will become horizontal. So that means the angle made by this tangent with the horizontal direction will be 0, and this theta is also 0. So that means as you are moving away from this point, from middle, as you are going down, tension is going in the downward direction, and so is this angle. So that means this angle and this angle, they have to be equal. This is theta, this is theta. Similarly, this is theta, this is theta. Okay, so this is another critical observation. Now, if this is T, this is theta, what will be the horizontal component? It will be T cos theta. And here you will have T sin theta. Similarly, for this theta, the horizontal component, this will be T cos theta, and then again the vertical component will be T sin theta. So this will become 2T sin theta. Okay, now here again, if you have this doubt, like this is T, this is theta, this is Tx, this is Ty. Okay, so if you use, suppose this is a right angle triangle. Okay, so what will be cos theta? Cos theta will be Tx by T. So Tx is equal to T cos theta. So that means this is T cos theta. Okay, now similarly in the same triangle, what is sin theta? Sin theta is Ty by T. So Ty is equal to T sin theta. So that means this component is T sin theta. Okay, so this is how I have resolved this T as T cos theta, T sin theta, this T as T cos theta, T sin theta. So this T cos theta, they are in opposite direction. Okay, now in vectors we have seen that if we have two vector quantity in the opposite direction, what is the resultant? The resultant is 0, because they have equal magnitude. So this t cos theta component cancels out. Okay, so this components cancels out. Okay, so there is no component of tension in the horizontal direction. So only component of tension is in this direction, radial direction. Okay, now what is this force tension in the radial direction? 2t sin theta. So in the radial direction, see this segment AB, this tension, it is acting in the downward direction, means towards the center. Okay, but there is a repulsive force between this charge and the charge of this segment, and that repulsive force will act in this direction. That is the electrostatic force, repulsive force. So this is Fe and this is 2t sin theta. Okay, and the system is in equilibrium, and under the equilibrium we have this expression for tension. Okay, so we have to find the value of this tension. Okay, so how to find this value? So now we have to use some simple mathematics. Like we have to equate these two forces. So 2t sin theta is equal to Fe. To write the expression for Fe, we are going to use Coulomb's law. So that is K Q, this charge, then charge on segment AB. So that we will write as QAB, because I don't know what is the charge on this segment. I only know that the entire length has charge Q, capital Q. So divide by R square. Okay, this I can write. Okay, based on our understanding of whatever we have discussed till now. Now, what is this QAB? QAB, can I write it like this? See, Q is the total charge on the ring, and twice by R is the total length of the ring, because R is the radius. Correct? R is the radius. So since R is the radius, length will be twice by R, circumference. So Q by twice by R is the charge per unit length. Q by twice by R is charge per unit length. So charge per unit length, if I multiply with the length, AB length, arc length AB, then that will be the charge on the segment AB. Okay, charge per unit length into length will give you the charge on the length. Correct? So this QAB is this quantity. Now in this beginning I told you this A and B, these are very close to each other. Okay, so since they are very close to each other, that means these angles, they are very small. Okay, so for small angle, this sin theta can be replaced as theta. Okay, so substituting the value of this sin theta equal to theta in this expression, what do we get? This becomes 2t theta is equal to k q. QAB can be replaced by this term. So this is q by twice by r AB divided by r square. Okay, divided by r square. Now this 2t theta, this can be written as t into 2 theta. So 2 theta is this total angle subtended by this arc AB. Okay, now the definition of plane angle is angle equal to arc length by radius. Obviously this is in a plane. Okay, so this is 2 theta is equal to arc length AB by r. Okay, so if I substitute this value over there, what do I get? T arc length AB by r is equal to k q by twice pi r cube AB. Okay, so this twice pi r into r square becomes twice pi r cube. So this AB gets cancelled. So this r, this becomes r square. Okay, so now we have the final expression for tension. T is equal to KQ by twice pi r square. Okay, so now let us replace this K by 1 by 4 pi epsilon naught. Okay, so I have replaced this K by 1 by 4 pi epsilon naught, because see, nothing is said about the medium. If nothing is said about the medium, then we have to assume that this arrangement is placed in free space. Okay, So K is equal to 1 by 4 by epsilon naught. Here epsilon naught is the permittivity of free space. So this becomes T is equal to QQ by this becomes 8 pi square epsilon naught R square. Okay. So this is the final expression for tension that is developed in the ring because of placing this charge Q at the center of the ring. Okay. So this is how you have to approach a particular question. Okay. So here I have discussed one particular case, but you can apply this technique to solve other questions also. Okay. So hope this video benefits you. My best wishes.